While the evidence is strong that the continents have drifted to their present locations and continue to drift, the question remains, how do they drift? Scientists have developed a theory to explain continental drift. This theory is called the theory of plate tectonics. According to the theory of plate tectonics, the Earth's surface is located on top of large blocks of rock called plates. These plates actually float on the partly melted rock of the Earth's mantle. Heat inside the Earth creates currents in the upper part of the Earth's mantle, which is putty-like and can flow under pressure. These currents move very slowly, but they are so powerful that they can push different plates together, apart, or past each other. One place where plates are moving apart is the Mid-Atlantic Ridge, part of an extensive system of mid-ocean ridges that stretch along the bottoms of all the Earth's oceans. Running down the middle of a mid-ocean ridge is a kind of valley called a rift. The rift marks the exact boundary between plates. As the plates move apart, hot liquid rock from deep within the Earth pushes up through the rift and onto the seafloor, where it cools to form new crust. A place where two plates are moving apart like this is known as a spreading boundary. But what happens when plates collide? To see what happens, take two towels. Imagine that each towel is a separate plate. Now slowly push the towels together, and note how they bunch up when they collide. The same thing happens when the Earth's plates collide. Mountains form when the land buckles upward. It can take millions of years for such mountains to form. But at the boundaries between different plates, changes in the Earth's crust also can occur very quickly. In fact, we can witness some of these changes as they happen. Volcanoes erupt when magma, hot liquid rock from inside the Earth, forces itself through the Earth's crust. Many volcanoes occur near colliding plates. As the crust of one plate collides with another, it is forced underneath into the Earth's mantle, where it melts, forming magma. The magma may then move upward through cracks and openings in the crust. The heat and gases trapped in the magma can build up pressure until finally it explodes out onto the surface. Earthquakes provide another example of changes that occur suddenly on the Earth's surface. In 1994, much of Northern California was rocked by an earthquake that caused extensive damage. Buildings and highways collapsed. The earthquake destroyed whole neighborhoods and forced people to abandon their homes. What are the causes of such destructive quakes? Once again, plate tectonics provides an important clue. The San Andreas Fault in California, the site of frequent earthquakes, marks a boundary that you can actually see where plates slide past each other. As these two plates move past each other, they exert enormous pressure on the surrounding rock. What can happen can be compared to what happens when you slowly bend a stick. The more you bend it, the greater the stress, until suddenly it breaks. In a similar way, earthquakes occur when rock bends as plates move under a great deal of pressure. Like a stick, the rock can suddenly break, releasing a great amount of energy that causes the ground to shake. Along the San Andreas Fault, scientists are trying to better understand this process by actually drilling deep into the boundary between two plates.
The drilling project is an attempt to get into the San Andreas Fault in a place where small earthquakes occur and where creep is occurring along the fault. We want to measure the basic forces that drive the fault, understand the fluids that help in its motion, understand the minerals and their strengths that occur within the fault zone, basically to try to understand the clockwork of the San Andreas Fault.
By better understanding what happens along fault zones, scientists hope to be able to more accurately predict earthquakes and reduce the amount of destruction they cause.